We're going to be learning today about kinematics, 1D horizontal motion, and basically, well, the first thing that we have to learn about in this unit is basically what is kinematics. The study of motion without considering its what is causing the motion involves both spatial and temporal changes. Alright, and we also have to know what the definition of vector quantity is, which is basically has magnitude and direction and can be added to find the resultant vector, like displacement, weight, or velocity, right? Alright, so direction, that's like a point. That's like a point towards something determined by its orientation and sense. So, and displacement is a change in position. Like if I have an object right here, and if I move it here, that's displacement, right? And position is the location of the reference frame, a body's physical location in space. So anyways, and distance, well of course, that's how far two objects are at, right? So anyways, let's begin. So, the main equations for kinematics 1D is they're gonna do this triangle thing that's gonna be like, triangle x, delta x equals distance x minus initial x, which is the placement of the equation, and all that. And then all of a sudden you're going to find out, in order to find velocity, it's going to be velocity equals delta x divided by time to find average velocity. Also, to find the acceleration, you're going to multiply velocity final, and you're going to subtract that from velocity initial in order to find acceleration. And now to find distance, delta x minus initial velocity plus 1/2 acceleration and times time square rooted. And that's in order to find the distance. And in order to find velocity in total, you're going to do velocity squared equals velocity squared plus 2 times acceleration times delta x. And delta x is basically the displacement of the object, like where it's at. So, yeah. Now, anyways, the other stuff that we haven't learned yet, well, basically there's some other definitions that we must know. Air resistance, for example, is the force of an air opposing motion. So if I throw an arrow facing towards you, all the air that's facing towards me is going to like make that increase or decrease the speed of that arrow. We're also going to know we also have to know what speed is, which is how fast a body is moving, like distance change in time. And we also have to know what the slope is, which is obviously the incline of a line on a graph from the horizontal axis. And that is all for today.
Now this is demonstration of kinematics in 1D motion. Horizontally, it's approaching a stoplight with a velocity of 30 meters per second. The light turns yellow and Steve applies the brakes and skids to a stop. If Steve's acceleration is -8 meters per second square, then determine the displacement of the car during the skidding process. In this problem, you have to find the displacement, right? And what is given is VI, which is 30 meters per second. And then it said that Steve applies the brake and skid to a stop, so VF is 0 meters per second. And it also gives us an acceleration of -8. And then we have to determine displacement, right? In this case, we're going to put it to equal x, set it to equal x. And in this problem, we have to use the formula VF squared equal VI squared plus 2ax. And in this problem, you're given VF as 0, so 0 to the power 2 is 0. But VI, you're given 30. And then plus 2, acceleration is -8. to the second power is 900. And then 2 times negative 8 is 16x. And then the f is still 0. And you move you move 900 over, which is negative 900 equals negative 6x. And then you isolate negative 6x. Negative 6x is 16. And then x equals 916. And that is our answer.
Welcome to another AP Physics study session with here Scott Sanchez and my student Alejandro Chicas. Well, today we're going to be learning this lab about kinematics 1D horizontal motion. So right here what I have with me in my lab equipment, I have 2 textbooks that are going to serve as a stopping point for my car. And I have a car obviously, and a track used for my car to actually ride on. And then right here we have a motion detector, which, what does it use, Alejandro?
It's a position versus time and velocity versus time graph.
Good job. So right now, I'll demonstrate a demonstration of how to do this lab. So all you're gonna do is basically just move the car and then find out what's the time, position, and the displacement. Do this trial 3 times, and that'll be all.